Good afternoon. Thanks for giving me this opportunity. And first, I want to correct it. I'm not doctor at all. I am a biomedical engineer and responsible for installation and commissioning the linear accelerator machines. So earlier I informed David Franklins. Always they call me doctors, but I am not a doctor. So this is for your kind information. I am biomedical engineer. So I'm working in Trade Vision Limited last 5 years, and prior to that I work in National Institute of Cancer Research and Hospital, the same position, and I switch from the National Institute of Cancer Research Institute and Hospital to Trade Vision Limited. I trained from Switzerland in Variant Medical Systems, installing and commissioning the beam data configuration of linear accelerator machine and different energy. So my topics is SSD and electron beam data depth dose. So my two co-author, unfortunately, they don't here. They are now in ICTP in Italy for advanced biomedical conference. They are attending last 2 weeks. So I'm using the 4 linear accelerator machines. You see there is two machine. The left one is the OBI machine and the right is the dual energy machine. Both are the machine is dual energy. So unfortunately I didn't get here any IMRT and rapid arc or VMAT facilities here. I know the VMAT and rapid arc and IMRT facilities good for cancer patient. So unfortunately, I didn't get there for this institute. So for commissioning purpose, I use the water phantom. This water phantom is 3D water phantom. So there is a lot of water phantom. I use this water phantom. It's provided from the PTW, 3D water phantom. So my topic is electron beam. So why we use electrons? So the linear accelerator machines have the electron and photon also. So I use the electron energy. So why electron energy? Delivery is reasonable uniform dose from the surface to a specific depth after using dose falls off rapidly, eventually to a near zero value. Using electron beams allow discuss within approximately 6 centimeter of the surface to the treated, effectively sparing deeper normal tissue. So there is some equations where I get the data from the water phantoms. And I take the data from the different kind of field size, like 6 by 6, 10 by 10, 15 by 15, 20, and 40 by 40. This is the 40 by 40 is the maximum field size for large field. We can use it normally 40 by 40 field size in the cancer patients because this is the huge field size. The materials, I use the electrometers. There is two type of, many kind of electrometers. I use the left PTW unidose electrometers. And there is the chamber. I use the Fermat chambers only. I didn't use the pinpoint chamber. This is the frame I want to use from the control and also indicate the software also. This is the Mephisto MC Square software what I can use for this. I want to use here and I change it from the energy and I will take different kind of field size and also the depth, dose depth. Here you see the upper is the LINAC and measurement. I use only the measurement, but LINAC is the previous. You see the previous where I can input the energy and also field size. This is the measurement. What is the depth of my dose delivery to the phantoms, and I use the field size also. When I start the beam on, that time I will see the right side diagrams. You see there is a lot of diagrams. When we use the small field size, if the field is smaller than approximately 4 by 4, If the focus is rapidly hidden by the collimators, if rapidly electrons, uh, sorry, if literal electrons equilibrium is not even in the center of the field, air density. This is the most important thing. So when I get the value from the water phantoms by using electrometers and the chambers, the air density is the most important thing because the humidity is the one of the part of the measurement. Laser positioning. When I created the water phantoms to the gantry head, the gantry head must be 0 degree, collimator also 0 degree, laser positioning also the 0 degree. Laser positioning will center point of the water phantom and gantry head. This is the electron beam productions. You see there is 4 kind of jaw 1, jaw B, and X1 and XB, Y1 and YB. This jaw is reduce the radiation from the extra radiation from the gantry head to the patient. You see, there is electron mounted applicator. There is so many kind of electron applicators. I use the 5 applicators in as I need. The electron energy for treatment should be selected such that the depth of the 90% isodose, the line converted at the deepest portion of the region to the treated in addition to an approximately 5 mm. Additionally, depth beyond the treatment region. The depth of RGO can be approximately by dividing the energy of the electron in MeV by 4 in centimeters of water. Central axis depth dose distribution in water. There is many kind of electrons energy. In our institute, we available, you see there is 4 MeV to 25 MeV, but we are available 4 MeV to 23 MeV. See the dose distribution beyond Z max. Spectrum of the electron beam depends on the points of measurement in the beam. Clinical consideration in electron beam therapy. Electron beam therapy is usually applied in treatment of superficial or subcutaneous disease. Treatment is usually delivered with a single direct electron field at a nominal SSD of 100 centimeters. The dose is usually prescribed at a depth that lies at or beyond the distal margin of the target. PDD for small electron beam. So for decreasing the field size, when the field of the field decreases to below the RP value of the given electron energy, you see there is the graph where we find the 4x4, 6x6, 10x10, 15, 20, 20x20, but we didn't use here 40x40 field size. Field shaping. This is the most important things for field shaping. To achieve a more customized electron field shape, a lead or metal alloy cutoff. You see that there is a many kind of rule. As the rules of thumb, dividing the particle range by the 10 of to obtain the approximately thickness of lead requires for shielding less than 5%. For certain treatment, such as the treatment of the lip, there is a lot of things you may. Oh shit. See, the last one is internal shield, as usually coated with low atomic number materials to minimize the electrons back scattering into healthy tissue above the shield. Electron arc therapy, but we didn't use it electron arc therapy because we don't have any VMAT or rapid arc system in this institute. Dose distribution into water, depth dose, measure attraction of the electron beam irradiation is the shape of the depth dose curve. The depth is centimeters at which electrons delivers a dose to the 80% to 90% isodose level. Most useful treatment depth of therapeutics range of electrons is given by the depth of the 90% depth dose. We got this result for different kind of energy. Like 6, 8, 10, 12, 15, and 18. After getting all the energy data, will a different field size and depth dose then convert the file into the ASCII format and put the data into the Eclipse beam data and match with the existing golden beam data. Finally, we got the new data is approximately same. Maximum deviation here is plus minus 2%, but it is accepted for the IAEA. You see, there is existing and the new data of from the phantom and the gantry. I use the reference from IAEA TRS 30 TG25 TG51. That's it. So, thank you very much. Have you any question?
One question.
Sir, please.
Can you go back to the image?
Sorry?
It's increasing, you are going deeper.
Hmm.
And the tumor will be deeper. Let us say 18 centimeters.
For your kind information, sir, I am not doctor, and the commissioning is depends only the biomedical engineer and the medical physics. The medical physicists, they are responsible for this. So I will not give you the right information for this because it is depends on the oncologist or the doctors.
No, you did not understand my question. The characteristic of the electron,
Hmm?
when they are shooting or they are treating the cancer
Hmm?
with the electrons, with X-ray photon, let us say,
Yeah.
which is coming from the linear accelerator.
Like cyclotron.
Yeah.
Okay.
So it will come with a high, you need very high energy entering the body
Okay.
because the curve is like that.
Yes.
So you can show me the curve. Yeah, that's right. That one. You see, when you are coming inside,
Hmm.
it's on the skin now. You are on the skin.
Hmm.
So it's very high dose. When you are reaching the tumor, let us say by 18 centimeters or by 9, the energy is less.
Okay.
You got my point. So this is what I would like to understand from you.
Actually, I works in the total guideline of variant medical system. So unfortunately, I don't give you the right information. So I'm applied for this your answer. Thank you very much.
Okay. Sure, let's thank the speaker again.
Thank you.